Developers, can you hear us? Can you see us? I have a very special guest for you today. We are talking all about the data science career field here on the Real Tough Candy channel. Now, for those of you who know this channel, we do software here. We do web development, but we are talking about data science today because a lot of you have been asking about it. How do I get into it? What the heck is it even? I have a very special guest today. Her name is Jen. She's from the Career Force. She's been doing this for 15 years, so she knows her stuff. Jen, welcome to the Real Tough Candy channel.
Thank you so much for having me on. I think this is a great overlap with software development, and it doesn't shock me to hear you're getting questions about it, because I think a lot of people that are new to data science, or maybe are just hearing about it, see a lot of overlap with software development. And so hopefully we can clear up a lot of things for people.
Awesome. So before we get into the meat and the protein of this interview, tell me a little about yourself and your evolution to what you're doing today.
Sure. So right now I run two different businesses. I have my own consulting company where I do data science for companies, primarily companies that don't have in-house resources to do it. Sometimes larger companies that just need some supplemental support. And then I also teach people about analytics and data science, how to get into the field, how to just use it more in their jobs, because there's so many jobs where a little more application of those skills can make them a lot easier, can make people more productive. So I've been in the field for 15 years. I used to work in a corporate role, doing the same thing in-house for a company. And I got into it because I got my bachelor's degree in math. I loved the statistics, the mathematical side of it. And when I was looking at how do I actually apply this, I came across data analyst roles, statistician roles that were taking it and really solving real problems for companies. And I really liked that. I knew I didn't want to teach. I knew I wanted something where what I was doing fundamentally impacted what the organization was going to do. It created direction. It helped make things more clear. And so I loved it. I have stuck in it in different roles. Yeah, I really, really enjoy it. I think it's a great field.
Awesome. So before we got online to do this live, you were telling me before it was called data science, it actually was not data. It was not called data science. Can you go into the history of the naming convention just to clarify?
Yeah, so data science as a term is relatively new, like late 2000s, 2008-9 timeframe. Before that, most of the roles were called statistician, statistical analyst, maybe data analyst was starting to become popular around 2000 or so. So this job has existed for a long time. It's not brand new. I think where we started to see a lot of shift is in the early 2000s with the big tech boom that was happening, and just the widespread use of and quick development of stuff, we've started generating so much more data than we ever did before. And so now there's more of this shift on the data as the front, kind of the standout piece, rather than the math is almost kind of secondary of what people think of, if they even think of it. And that's something I think we'll talk a little bit more when we get into skills. So now if you look for data science positions, they could show up a number of different ways. You might actually see data scientist roles, but roles like machine learning engineer or quantitative analyst, if we look at finance, or statistician is still what the US government and a lot of governments around the world, that's still the term that they use to decide to describe the role, even though it's exactly the same thing as a data science role.
Sure. So when I hear the term data scientist, I'm thinking someone wearing safety goggles, the white lab coat, but this is probably not true, right? They wear normal clothes. Is this like a fair assumption?
That's a fair assumption.
Okay. So can you tell me like what a data scientist does on a daily basis?
Yeah, so I think what a data scientist does is probably not fundamentally that much different from a software developer, where you've got clients, whether they're internal or external, you're gathering requirements, you're looking at what are the problems the company is facing, and then you're trying to create a solution. So maybe if you're talking about web development, maybe that solution is a functioning website that performs specific actions. On a data science perspective, it's trying to determine what's the data telling us and what should we do based on what that data is telling us. So when we talk about analytics or data science, there's kind of a spectrum where you can look at the past, you can look at the present, you can look at the future. And analytics, as it's kind of traditionally been defined, has mainly looked at the past. So what happened, creating a report, like if we're talking about analyzing website performance, it would be looking at how many visitors did we have, where did they come from, segmenting that out. Where data science would try to evolve on that is look at what does that likely mean is going to happen in the future, what can I do to optimize that, if I tweak different inputs, how does that change the result that I get. And so that happens in a variety of different tools. The most popular for data science is still to code, to program in a tool like a language like Python, for instance. But there's also this growing movement towards no code tools. So ones that have nice GUIs where you really focus more on, you need to know the technical what needs to happen, but you don't necessarily need to know how to code to get into it. Trying to make it more accessible, but a lot of interaction with people, and then a lot of taking that problem solving, implementing some sort of solution that usually is going to different parts of the business, and that looks a little different depending on exactly the role, since there's quite a different number of roles you can be in that fall under a data scientist job.
Sure. So you had mentioned different tools with like nice GUIs. I'm thinking of like
Mhm.
Tableau. There's
Yep.
is there Power BI or Power BI? I don't even know how to pronounce it.
Yeah, Tableau and Power BI are really popular, and they're on what I would say like the data visualization end, where their primary focus is all about the visual. And you can get like tables of data and other stuff that's not visualized out of them, but they're really on the visual. Then on the more what I would maybe say technical end, less on the visual, more on the output, would be tools like SAS. SAS is a really big privately owned company. They've been doing statistical analysis software. I think that's what SAS stands for, since like 60s or 70s.
Okay.
And they have dozens of different tools that vary from no code at all, low code, up to they have their own language based SAS, and you can program entirely in that. But in a way, it functions similar to something like Tableau. So rather than having to code to maybe select the data that you're going to use, you just click through almost like an interface, not that dissimilar from Excel or Access, if people are familiar with those. You've got your ribbon that has different functions. You can easily add stuff without having to code in how to do it. And then there's other players in that. IBM has their own solution. IBM Watson Studio does a lot, especially they market mainly towards machine learning, but they're really good for any type of analytics. Alteryx. It seems like there's somebody new popping up every week, but I'd say in terms of kind of the big ones, IBM, SAS, Alteryx are kind of big in that no code direction.
Interesting. Okay. So you had mentioned earlier that web development, software development has a lot in common with data analytics and data science. Can you discuss or share how hard it would be for your typical software developer to make the transition to data science? Like what's some
Sure.
skills and like, what should they do to do that?
Yeah, so I think it's going to depend what their background is. So Python is, I know, really popular in software development, but it really depends on what role you're coming from. So it's not going to so much be for the average web developer, but if you're in a different software role, you might be extremely familiar with Python. And so then the focus would mainly be on packages that are more statistical in nature, NumPy, Matplotlib. There's a number of different pandas, that libraries that are more on the statistical side. But I think regardless of what language you know, that's going to feel kind of familiar, even if you need to learn a new one, or if you decide to learn one of those tools that is a no code or lower code tool. But the biggest thing is the math. And that's what I think we don't spend a lot of time talking about, even in the analytics, the data science world, is we focus a lot on the tools that we use or the languages we use, but really when it comes down to it, the math piece is what's really critical. That, and how do you apply it to a business scenario? So if someone was getting started, I'd say look at a statistics class. Definitely get familiar with that, because that's going to be the biggest gap when you're making that switch into a data science role, is understanding what you're doing. Tools can get you most of the way. They can do the complex math, but you still need to know, what is the analysis I need to run? What type of models do I need to use here? That's the place that the software can't really help you.
Right. So you don't need a degree to be a data scientist, but it definitely helps. Would you agree or disagree with that?
Technically you don't need a degree, but it's pretty difficult to get into it without some degree. There are certainly companies, and I think, again, it's probably the same ones that we've heard of, that your audience has heard of, or you've heard of, that are like, oh, we don't need to worry about degrees. It's what people have done. But the reality outside of most of those big companies that are getting the headlines is, it's going to be a lot more difficult if you don't have experience to get into the role without a degree, at least somewhat related. Any sort of STEM degree is preferred. Even if you have an unrelated bachelor's degree, it's still going to be a lot easier to get into the field with that, and then building your skills up, than someone that has no degree at all.
Right. Okay. Because there was like 2 or 3 years ago where some of the FANGs said, okay, no more degree. But there's still a lot of places out there who say we want a degree, even if it's not related, just for that credential. So yeah, that is, I agree with you when we said earlier that we don't talk about certain topics that are kind of inconvenient to talk about. But I mean, it's just important to get it out there that there are companies expecting a certain, that just like a suite of things or credentials to get into it. But like you said too, there are also companies who don't care if you have a degree or not. It's like what you did in the past and what your work history is, and stuff like that. So talking about now, shifting from the formal education to more of an informal or at your own pace education, what are some good resources aside from college you would recommend to people interested in exploring data science?
So the first place I would recommend someone start, if they're brand new to it, is a tool like DataCamp, that has I think, a really good way of holding your hand through the process of learning a language, learning some of the basics. And I think that's a great resource because it's pretty inexpensive to get started with. So it's a good way to test the waters and see if you like it. There's plenty of platforms online that have great training in statistics. So I would look at edX or Coursera, and there's companies like Google, and colleges, universities like Harvard, MIT, that publish classes on there. And I think they're a great resource to start learning and start building those skills. And then even if you would decide to go get a bachelor's or a master's in a related field, you're going to have a much better foundation. It's also a good introduction to see, do you like it? Do you like the math side of things? Because it's not for everyone.
Right.
But the people that do like it, love it. I love that aspect of it more than I like the coding aspect of being in data science. But that's not universal. So I would start with a cheaper method of doing that than going straight for a degree.
Okay, because I know on Coursera, some of they pair up with some pretty big names in the
Mhm.
education industry, like these, Yale and I don't know, Stanford, tons of courses, and a lot of them are free. And like you had
Yeah.
mentioned, it's good to just test the waters to see if you even like it, rather than go to college, spend $100,000, and then find out you don't like it. So there are cheaper options out there. Oops, I just dropped my pen. Sorry about that. So going on to the next question I have for you, let's talk about the stuff people are asking about: money. How much are entry level data scientists making their first year, and then what is the future of that?
Yeah, there's a huge spectrum because there are so many specialty areas. So, on the low end, if you're in a non-tech role and you're in not a major city in the US, you're working for a local company or mid-sized organization, you might be in the like 70 to 80,000 range. However, when you get into tech roles, average positions are more like low 100s, even for entry level. Averages 110 to 120, even outside of tech. Within tech, especially the FANG companies, it goes up from there. I think Facebook's data science average is somewhere around 145, 150 base salary.
Mm.
And then kind of on the extreme upper end usually ends up being quants or quantitative analysts in finance, that are building the models for how companies are working with different stocks and what they're purchasing. And those positions can be mid 200s, upwards of a half a mil a year.
Wow.
But they also require a lot more education. So you're not going to jump into those right away. They're definitely the really math heavy. There's a lot of money. Everything you do is directly tied to money with those, where a lot of the other positions indirectly tie back. You can see the connection to how the company makes money, but it's not quite as critical as like if you're working on the search engine algorithm for Google or for Amazon. That's important and it ties to the bottom line, but a little change here or there doesn't necessarily have a drastic impact. Whereas in finance, it tends to be a lot more cutthroat in terms of the impact.
Sure. So at these employers, do data scientists have like their little corner, or how are they integrated with the rest of the company, or do they just do their own thing on like continuously, or what's that dynamic like?
Yeah, it's a little different company to company. I think the companies that are doing it best have them pretty integrated. So they're working in parts of teams, they're on projects, they really understand the business impact of what they're doing. And I think this is maybe one of the biggest differences of where data science has kind of evolved to and where it's going in the future is they're not just sitting in some roles. They currently are just sitting in a corner. Here's your work, go ahead, plug away at it. But the better positions that are really making use of that, they understand exactly what the business impact is that they're having. They understand what the business wants to accomplish. Because one of the things that role should be, ideally, is they're not just looking at this is exactly what the company says they want to do or what my boss or my team says they want to do, but this is maybe this other thing is what we want to accomplish, and there might be another method of getting there, because people are generally limited by what they know.
Mm.
If you're not familiar with data science, if you're not familiar with the math, the ins and outs of what can be done, then you can't really think through requesting one of those more unique or modern techniques to be used. So being really integrated is becoming more of a push in data science. They're part of teams. They're deeply involved in what the business is trying to accomplish.
Okay. And so as far as the job availability, what's the job market like now? Is there a huge demand for it, like relative to other jobs? And what do you see the future of that?
There's a pretty big demand. The Bureau of Labor and Statistics puts out numbers around a bunch of different jobs, and data science is one of their fastest growing jobs. I think it's something around a 15 to 20% increase in roles expected over the next 10 years.
Mm.
So there is good growth there. Companies, there's more and more companies hiring for it. Tech is definitely the more of a first adopter. They get a lot of value. There's a lot tied to data in the tech industry, but more and more we're seeing it in every other sector. Manufacturing, it's really popular. Retail, healthcare is huge, and I think we actually saw some really interesting solutions even the past year, thanks to data science, contributing to some of the research. There have been calls for research and analysis on available medical data with what's been going on the past year, but even solving problems that have existed for 50 plus years with AI and machine learning, which also all kind of ties back into that data science role. And that's where I think 10 years from now, data science might look different than what it does today. There's so much of artificial intelligence that is based on the data and builds off of that. And I think we might see more of a shift in even smaller companies going that direction in the future.
And that was my kind of follow-up question, because earlier we talked about, you had mentioned the finance industry, which is, you know, New York City, these bigger cities, Silicon Valley doing their thing with all those companies. But there's like a lot of room between those coasts where employers are hiring, and in these smaller, maybe smaller towns, maybe no one's heard of. Can you discuss that a little more? Like what, I mean, you'd mentioned healthcare is a big one, and every town, every city has a hospital. Like, is that where a data scientist could expect to work? Are they at, like, you know, a big hospital headquarters? Are they at the actual hospital? Like, how are they dispersed?
Yeah, it's a little bit of everywhere. I think in most cases, you're not going to find huge clusters of data scientists in one location. There are certainly employers that do hire a lot, but it's not that unusual to find places that have 2 or 3 people working in the role that might be working. For instance, I have a friend that works for the state of, I don't know if she works for the state of Pennsylvania or a hospital group that's big here. And so she looks at how do the hospitals perform relative to each other? How do different doctors perform? What are their patient outcomes? How costly is it to insurance? So really looking at performance, like if someone comes in to be treated for, I don't know, a heart attack at one hospital versus another, how likely are they to come back with another issue or with a repeat issue? How well are we solving that sort of thing? If we stick with healthcare for a minute, pretty much all of the big drug companies are employing data scientists because they're involved in clinical drug trials, in analyzing the information, preparing that, sending it to the FDA, I think it is, that does drug trials. I'm not sure, but preparing everything for that. In manufacturing, it's really popular. If we look at transportation, both like commercial and for more consumer, predicting what's the best use of a fleet of tractor trailers, where should they be going, predicting potential issues based on codes that the vehicle is producing. Are they likely to break down with a certain issue based on things we've seen in the past? Can something be done proactively? So there's really applications pretty much everywhere for how do you take the data, learn from it, and make a decision about the future based on it.
Okay. And so for people who are doing that type of work, they're not just, we talked about this earlier with these GUIs, they're not just like clicking buttons and saying, okay, what's the computer going to spit out? Like what's it going to print out their prediction? Like the data scientist is actively involved in this process, and they're critically thinking and, you know, using these formulas and stuff. Can you talk a little bit about, like, in software, especially in web development, we have different tools coming out, it seems like every week. Is that the same tempo in data science? Like how often are you expected to learn a new technology, and how often are you implementing new techniques or new technologies and stuff like that?
Yeah, it sometimes feels like that, that there's something new coming out every week. And there are so many companies that are releasing software to use for analytics, no matter how simple or complex it is, because it's a really popular topic. So they want to make money. In a lot of cases, they're adding some sort of value, maybe not that unique. But in terms of learning new technologies in data science, a lot of the fundamentals are the same. So Python is incredibly popular. It keeps growing in popularity. I don't see that disappearing. R is also popular. That's more of a statistical, has more of a history as a statistical software. The core things haven't really changed that much. I'd say it's more the techniques as we move further the direction of AI, machine learning, developing new models, developing new ways of working. One of the other topics that's coming up a lot is blockchain. So things that, like right now we hear a lot about with crypto, with Bitcoin, whatnot. But there's a lot of talk of how does that tie in with data science? And I mean, it seems like every day somebody is getting hacked, data's getting released. So that's another big piece. That's not so central to data science as it is maybe more of someone that's doing security type work, but it is really important because data is the central piece of every role. No matter what tool you're using, you need that data to be successful. So making sure it's not compromised, making sure that you can access as much as possible, that really is important. And I think we'll see more evolving over the next decade, however long, I'm sure even longer than that, looking at how do we secure the data, how do we develop new models that are better at prediction. This past year has caused a lot of companies that have been doing predictive modeling to kind of go back to the drawing board, because when you have things that interrupt what's been otherwise a pretty steady state of growth for a decade, it it ruins all your models. Your models are at least significantly based on the future being pretty similar to the past. So I think I'm anticipating that we'll see a lot of more focus on that going forward. Is how do we deal with adapting models for one-time events? What other predictors can we get in there? How do we deal with cycles that maybe some industries have dealt with a lot and other industries haven't dealt with so much? I think that's where I see there being so much room to grow, and our data increases exponentially every year. So I'm not even sure 10 years from now what we'll be talking about, but I think that the prediction aspect of things is really going to be where we continue to see change over and over going forward.
Mm-hmm. The thing that really, one of the things that stood out to me as a web developer learning how to code and all this stuff is just how valuable the data is. Like, not just the information you form out of the data, but the raw data itself, just to have it somewhere and as like a protein and as these building blocks for things that are very valuable, both from a monetary perspective as well as like a human perspective. Like, this is like the history of humanity we have in these databases, and people are using that raw material to just make these incredible things and these predictions and models. You had mentioned models. I just want to ask you like a very basic question. What is a model?
So a model or an algorithm is essentially just a set of instructions for how something should function. So you could almost look at it like a flow chart, where it's usually incredibly complex, but it's looking at, okay, this is my starting point. If I find this, then I do one thing. If I find something else, I do another thing. And then kind of working through at a simplest level, a bunch of if-then statements. If this happens, then do this. If not, do this other thing. And just building up that set of instructions to be incredibly complex, in many cases, taking in a lot of different factors at the same time.
Mm. Okay, interesting. By the way, developers, if you're enjoying this right now, you're enjoying this interview with Jen from the Career Force, please hit the thumbs up. We're going to be asking your questions in just a few minutes. I have one more question for Jen, and then we're going to take your questions. So please at me so I can see your comments, and we're going to get to them. So Jen, one more question for you. This is a really tough one. What is awesome about data science?
Everything.
But you love it. You've been in the career. You've been in there for 15 years. Like you don't want to. Like it's free. You love it. What do you love about it?
Yeah, I love that I am solving real problems, and so much of it, stuff that I've worked on, stuff that friends of mine or colleagues have worked on, solve real problems that really not just help the company, but make a tangible difference in people's lives. So I was trying to, like, I can talk about the excitement with that, but going back to the data, I thought, okay, I should pull up something that I could actually reference. So one of the things, if we go back to healthcare, that we've used data science to do is predicting early development of cancers. So specifically, there was one recently detecting lung cancer early, and based on the models that were built on data science, there was a 95% accuracy of early detection of lung cancer, whereas just looking at CT scans of the lungs, whereas when radiologists who are trained in this, who are really good at it, look at it, their success rate is about 65%. So that can make the difference between life and death in some cases, or early treatment or severity. There's so many applications where that automation, building off of the data, adds significant value to people. And I also want to mention that I think one place where people get a little uncomfortable with it is then they feel like, oh, well, is that working people out of a job? And in some cases it is. I think we can, I don't want to sugarcoat it. It's not like it doesn't replace any jobs. But I think when it's really used well, a lot of times it just complements it. So instead of focusing on how do we detect it, it's then those people that are specialists in what they do can focus on how do we treat it? What's the best way to address this? They can spend more time doing things where the human element still adds more value than what we've been able to develop our automations, our technology, our machine learning to be able to do. So I guess to wrap that all up in one statement, I love that it makes a significant, measurable, tangible difference in people's lives, mostly for the better. When it's used right, for the better. I really like that aspect.
Awesome. And you're not afraid of the robots taking over the world, just to be clear. Like, should we panic yet, or when? these autonomous robots just like doing everything. You're not concerned with this issue.
I'm not so concerned.
Okay,
I think
just for the record.
Just for the record. I would say, okay, maybe a little concerned.
All right, fair enough.
But no, I think that there's so many hurdles. I think the other thing that people forget is we see all of this stuff about like how fast AI is developing, all these things, and our capabilities and our actual rollout and application are very different time frames. Like we've had technology for autonomous vehicles to some degree for 2 decades now, and it's still kind of questionable in a lot of states in the US on are you even allowed to have that without a driver behind the wheel? So the adoption of things, I think, is going to take a lot longer than the actual development of the technology and being actually capable, or even bringing it to a scale of being accessible cost-wise for people to implement.
Right, because I know I used to be really into the trucking industry, and I was subscribed to a bunch of trucking channels, and I know that was a concern for some drivers who are saying, these self-driving semis are going to take my job, but other people have said that's not even going to be a thing. We don't have to worry about that for like 5 or 10 years to even start thinking about that being a threat, or them robots taking over semis. But yeah, it's just, I know a lot of people, oh, because you think about so many, everything involves software these days. Like there's nothing that is completely analog in the modern world. And it's just like, it is something I think a lot of people think about, like, wow, is my job going to be taken over by a computer? But then you have people who say, this is why you need to get into STEM, because we need people to run these computers and, you know, tweak the models and do different things and maintain the computers and stuff. So
Mhm.
yeah, and I think, you know, what you do on your channel, by the way, developers, check out her channel. It's Career Force on YouTube. And you also have a website, right?
Yeah, thecareerforce.com.
And you,
So
okay, yeah. And you talk about education and what, tell us more about that, what you do with that.
yeah, so I talk about data science, data analytics, business analytics. There's a lot of overlap on basically data focused careers, careers that focus on analyzing data. So I talk about different software, what to learn, areas to focus on, to help people get into the field, to help them grow their skills, become more analytical in what they're doing.
Awesome. Check it out, developers. All right, we're going to go to the questions now from the audience. Let's see. Developers, if you have a question for Jen, leave it in the chat here. I'll read it aloud. Give me 1 second here to get over to the comments. Orlando, sorry, I thought Orlando asked a question. It's actually Eugenio asked, should I study SQL besides Python and R to become a data scientist?
There are a lot of people that use SQL. I personally don't think it's necessary for every role. And if you don't already know Python or R, I would pick one and focus. So one of the things that happens a lot that I see as an issue with people getting into data science is they think, I'm hearing about these half a dozen different things, I need to go learn them all. And speaking as someone who has been a hiring manager in the past for people coming into these roles, usually what that means is people know a little about a lot and nothing in much depth. So you're much better off to focus on one thing, like focus on Python. Python's the most popular right now. So that's where I usually point people. R isn't a bad choice by any means. It's just, if I'm splitting hairs, pick the most popular one. That's where most of the jobs are. So learn Python, learn that in a lot of depth. Make sure that you have ways you can demonstrate that experience. So do projects on your own to build those skills, and then look at adding on R. If you want to learn SQL in parallel, that's fine. But I would focus more on Python or R instead, learn them in a lot of depth first.
Okay, excellent. Molly wants to know, what are the tools you're using? Your text editor, your favorite libraries and frameworks?
What tools am I using? So I use a variety of tools personally in my business. So I am using Python for some things. I also use Tableau and Power BI because for a lot of the companies I work with, my goal is for them to be somewhat self-sufficient, to have dashboards that they can look at and make decisions off of. With Python, I mainly use Spider and Jupyter Labs or Jupyter Notebooks to contain everything. In terms of like the libraries or packages you should know, Pandas, NumPy, and Matplotlib will cover the vast majority of things that you'll want to do within Python when it comes to data science.
Okay, awesome. Let's go back to the questions. I think we have one from Ruthie. She wants to know what's the hardest challenge people face in this field?
The hardest challenge, for some people, it's that if you're in a company that that is hearing about data science, they're like, I need a data scientist, but they don't really know how to use it. There can be a lot of work that doesn't get used, or a lot of changes that don't happen based on the data. And so that can be frustrating. On the other end, I think for companies that are well adapted, that are using it, right now is a really challenging time because like I was mentioning earlier, all your models that worked a year ago don't work anymore. If you're working in a company predicting what the sales of, I don't know, fruit or anything is, the models that a year ago were flawless, like 99.99% accuracy, are out the window. It's kind of a crapshoot on what's working, what's not. That's maybe a little extreme, but there's events like this that I think in the past we would have called once in a lifetime. And I would hope that this specific instance is a once in a lifetime. But the reality is, with the change in technology that we're having, we see disruptive events happening, and that does fundamentally kind of reset what you're doing that need to start over. For people that are just getting into the field, I think the biggest challenge is applying your skills to an actual business problem. So this is kind of across the board, no matter how much education you have, something that I've run into with people, from people that have an associate's degree or are still in college up to people with a PhD. Having technical skills is not enough. You have to know how to take those and solve a problem for the business to really be useful. And that's a really hard skill to learn. And it's something that we don't really have a lot in our education system. So that's definitely a big challenge for people that are just getting into it, is how do you take all of this technical knowledge and solve a real problem?
And speaking of PhD, we actually have someone in our chat right now, Dr. Candace. She is a software developer and she crossed over to data science in the healthcare field. So shout out to Dr. C. How's it going, Candace? I want you on this channel. We're going to interview here too. We're going to do, because we've had so many people ask about data science, we're going to be doing more interviews with different people and, exploring more just avenues for data science, because as we've been talking with Jen, there are just so many options, there's so many choices and paths to pursue, so many employers. You had mentioned a lot of, we talked about it just briefly, but government employers too, or government agencies. What do they need data scientists for?
Yeah, they need a lot of it for the same thing that the private sector does. So making decisions off the data, how do they spend money more efficiently? How do they use resources to help more people? How do you focus on, if you have a certain amount of investment for infrastructure, where does it go? And I'm sure the private companies, the politics are bad. I'm sure the government, the politics behind all of that get even more complex because there's actual politics involved.
Right.
But I think it was either earlier this week or last week that the government opened up, I think it was, I want to say it was 500 data scientist positions that they were hiring for, kind of across all different kinds of agencies. And within 2 days, they had maxed out the applicants their system could accept. So they're hiring a lot, they're needing a lot. They put together a lot of statistics that get published. So if you want to see a lot of their work, go check out the Bureau of Labor and Statistics website, and you'll find everything from what unemployment is like, what the forecast for unemployment in the future, who's employed where, how are things performing, like around the election. Pretty much every state had different data scientists that were creating reports that were publicized that you could go track how many ballots had come in versus what were sent out. So anything dealing with data, and there's a lot of it in the government, IRS, pretty much every agency has some amount of data scientists, or usually they're calling them statisticians employed.
Okay, excellent. Paradoodly Do is asking a question. She said, you referenced last year essentially destroying a decade of predictive data. How exactly do you adapt to that as a data scientist?
So I think where we take our first clues, I'm not going to pretend to be able to solve this, because if I could solve it, I think I'd have people knocking down my door for the solution. But in my corporate experience, most of my career was actually in the trucking industry. So it's interesting that Candy, that you mentioned that. But industries like that have dealt with cycles, and they've dealt with ups and downs because of disruptive events. So in that industry, it has a lot to do with emissions regulations changing, and that changing how many vehicles people are buying, when they're buying them, having slumps there. So I think here, one of the things that you start to look at is what other indicators that we hadn't previously considered might be valid. So typically when you're predicting what's going to happen, you're looking at what are the different factors that accurately tell me or accurately influence the thing I'm trying to predict. So you start looking for other indicators. You start looking for maybe you have shorter term models. Maybe now it's hard for me to say 5 years from now, what is our demand going to be? But maybe I can have a pretty accurate 3-month prediction. What else can I factor in? So like if I was working as a data scientist for a toilet paper company, I would factor in the fact that, yes, there's a massive increase in demand. It doesn't mean all of a sudden we're going to continually sell 1,000 times as much as we sold before, because there is only a finite need for it. So you start looking at what other factors might play in there. How does different sentiment play in? There's been a lot of hobby industries like biking, running, fitness that have actually seen a lot of increase over the past year. So you start to look at like how are things doing? What other factors can I maybe take in? And you start to narrow in a little bit. I know the longer out I look, it's going to be less accurate. How do I get more accurate shorter term to try to deal with that, and know that my model is going to have to change going forward.
So yeah, that's an interesting point you bring up, because the model doesn't have to be, these things are dynamic and changing. It's not like, here's my prediction for the next 10 years. Like you have to be very flexible, I would imagine, to take all this data, make the prediction, use the modeling software, whatever else you're using, and then, but continue to take in more data and change as you get that data, right? Because you're not just like saying, well, here's my 10-year prediction, goodbye. Like you're updating this stuff, and it's very dynamic.
Yeah, so one of the things that would be an easy modification right now to make is if I have a model that takes 20 years of history into account, I might discount the first 19 years more than I would have in the past, because I know that that was not what recently has been experienced. That might still be accurate if we're looking at a 5-year forecast, but if we're looking at 2021, what's going to happen, I would probably discount a lot what happened before the beginning of 2020 and say what's happened in the past year is probably more accurate. And this is where we talk about it, science, like it's all the math, like there's purely one answer, but there is so much that can turn into a creative direction, and it's understanding the industry, it's understanding the data you're looking at, and sometimes you have to adjust in a way that your science doesn't tell you, because what your science is telling you is I can predict with a 10% accuracy what's going to happen. And so that's where I think it can get really interesting, that the more you know, you're kind of figuring things out. You're using your expertise and what you know to do that prediction, where the math, the science can't support it because things have been too disruptive.
Okay, excellent. Progress wants to know, what is the difference between a data science and a machine learning engineer?
I would say that data science is kind of a catch-all for dozens of different roles, and I would consider a machine learning engineer to be a type of data scientist where they're specifically focused on machine learning, where their product, the data is their product. But I think it's just one of many, many segments within data science.
Okay, great. We have kind of another career question here from James McMillan. Wants to know, what would be a path to becoming a data scientist from someone who's a marketing analyst / data analyst working for an agency?
Okay. So the good thing is you already have some analytics background, which is great for data science. I would start ramping up those skills that are future looking. So if you're probably doing some amount of prediction when you're recommending what sort of marketing campaign should we do. So look more going forward. How else can I build on those skills? How can I bring more data into it? How can I get more minute in what I'm dealing with? So maybe looking beyond just which web pages are people using, but even looking at how much time are they spending on different segments based on how the site scrolls, if that's something you have access to. I think it's always great when you can build in your current job more of those skills, because it makes it easier to talk about on your resume. It makes it easier to talk about in interviews, and you're helping yourself be better at your job. So it's benefiting your employer as well. It's making your life a little easier. If you're not using a programming language or one of those more general no-code tools that we talked about, like Tableau or Power BI, SAS, Alteryx, I would build up skills in those. I know in marketing analytics, Google Analytics is kind of the gold standard, and I'm sure that's something that you know working in that field, but it's really not used outside of marketing very much. It's also functions a lot differently than most other analytic software. So that would be something that I would look at, is making sure that you have a tool, even if it's a no-code tool, that you know well, that you start looking at how can you get more forward-looking, and then think about if there's a specific segment you want to be in. So we just talked about machine learning. If you want to be a machine learning engineer, then build up skills in machine learning. I usually tell people, try to get somewhat specific about what you're going after, because there's less jobs, but the people that I work with that have the most success usually have some niche expertise, and that sets them aside. So they're not qualifying for every job, but the ones they do qualify for, they're much more highly qualified for than others. So build off of that marketing knowledge and look at how can I be even better? How can I have really accurate predictions in what I'm doing? Because that means a lot of money to a lot of companies, and bringing that marketing knowledge gives you an advantage for those types of roles.
And I just want to emphasize throughout this interview, you have mentioned multiple times that data scientists, they're the people making the big money for companies, right? They're not just like, well, I think we kind of need a data analyst. It'd be nice to have on our team. Like these people are critical to making massive amounts of money because they're problem solving using their technical skills. Like that's a big deal. Like no matter what industry it is, playing that critical role. And I know for software too, for doing like web development, another thing I realized earlier on in my career is that we get paid to solve problems. It's not just, well, I know React, I know JavaScript, I'm kind of good at PHP. It's not just the tool set, which we kind of talked about earlier, but that is important. But the bigger issue is solving a company's problems so that they can succeed and grow. And talking with you, I didn't realize what a prominent role a typical data scientist plays in that company, so directly related to a company's growth and their actions based on the profits. So good to know that these people are very important. Mm-hmm. Awesome. Okay, does anyone, we have time for one more question. Let me see if I can scroll through here. Developers, thanks for tuning in today. Again, I'm talking with Jen from the Career Force. She has a YouTube channel. She's been in this game for 15 years, very knowledgeable about this career field. One question I had, not from the chat, but one of these questions wanted me to ask you this, inspired me to ask you this. Do you know of any resources where people can just maybe not necessarily learn data science techniques, but learn about the different career fields? Just like, what are their options like? Because there's machine learning, there's, the data visualization. Do you have any good recommendations?
That's a great question, and I don't have a great resource to reference.
Okay, yeah, no worries.
I think that's one of the challenges right now, and really part of why I'm doing what I'm doing is that even when I had been in it for well over 10 years, I felt like the information was so disjointed about what's even my option. What if I was talking to somebody that's getting into it, what can they choose from? And there's just so many different titles. And I think there's also this push of everybody wants to feel like their role is unique. And there are a lot of unique roles, but there's also a lot that's not so unique, that that it's just really a segment within the broader data science headline.
Okay. Anything else you'd like to add? Last words, words of wisdom? The mic is yours.
If you're interested in data science, get into some of the math and see if you like it. I think that it is really fun. I think the worst case is you're going to find you hate the math, or you're going to find you don't want to work in it, but it makes you better at your current job. You find other ways you can use that data that tells you things, or depending on the type of company that you're working at or working with, it might help you interact with those organizations more. I think being familiar with the data side of things, if you're, say, freelancing and pitching a company, it is really helpful to be able to go back to the numbers and to tell them, this is what you can expect. This is what we typically see. Because that, especially if you're interacting with a bigger organization, that drives a lot of decision making. And so that could be a piece that sets you apart, even if it's something that you don't move forward with as a career. But try the math, see if you like it. I think for everybody that's watching this channel, they're probably somewhat comfortable, at least with the idea of coding. But that math side is something that some people love, some people hate. Figure that out early on before you take the time to learn the language or the tools.
Awesome. All right, Jen, thank you so much for visiting the channel. Very informational today. Where can people go to follow you or find out more about you and learn more about what you do?
Yeah, so look me up on YouTube, The Career Force, or visit my website, thecareerforce.com. I have a lot of resources on there, different trainings. I do one-on-one coaching with people that want to get into analytics, data science, or just want to build up those skills more. So if you go to the website, that links to everything else that I'm involved in and all kinds of resources.
Okay, and that is the website one more time for us.
Thecareerforce.com.
All right, developers, thanks for tuning in. Jen, thanks again for joining us. TGIF, and come back on the channel anytime and talk about data science. I know we got a lot of people in the chat today who are really interested in this career field. So thank you very much for coming on.
Thank you so much for having me. It was really fun to talk about it. As you can tell, I love talking about it.
It's awesome. After 15 years, you're still not sick of it. That is, a lot of people never find that connection. So it's just really great to see that you enjoy what you do, because there are a lot of people out there who don't enjoy what they do. It's not a pretty sight. All right, Jen. All right, everybody. Thank you so much. And we'll see you later.